I have the expression x plus 1 over 2 all to the power of 10. And if I want to expand it, I can easily use the binomial theorem formula, which was explained in the previous video, by the way. You can go there first if you haven't. And I will find the expanded form of all of this. But that is too much. I don't want that. What if I want a specific term of the expanded form of this expression? Do I actually have to do the whole expanded form so I can find this specific term? In today's video, we're going to find out how we can find a specific term without actually expanding the whole bracket. Welcome to my channel, Phi and Maths with an S. Yes, the S is intentional, providing physics and mathematics tutorials for secondary level and beyond. Make sure to subscribe to easily find all lessons and to write down any requests that you have for lessons in the comment section. Now, in order to find a specific term in an expanded form of a bracket, we need to have a general term rule. That is to say, a general rule that I can find any term with it. Now, if you look at the expanded form of the binomial theorem here, you can say that this is the first term, the second term, the third term, and so on. This is what we mean by terms. And we can immediately notice that in the first term, I have NC0, which is 1 minus 1, by the way. In the second term, I have NC1, which is 2 minus 1, by the way. In the third term, NC2, which is 3 minus 1, and so on and so on. So if I have a general term that is, let's say that this TR, I know that the coefficient of this term is going to equal NC R minus 1. R here. So if R equals 2, it's going to be NC1. If R equals 3, then NC2. If R equals 4, then NC3, and so on. Now, if we look at x here, x is raised to the power of 1. X is raised to the power of n. And here x is raised to the power of n minus 1. And this one is also 2 minus 1. And here x is raised to the power of m minus 2. And so it's 3 minus 1 equals 2. Even in the first one, it's n minus 0, which is 1 minus 1. So I can say that in a general term, x is going to be raised to the power of n minus r minus 1. For example, in the third term, x is raised to the power of n minus r, which is 3 minus 1. 3 minus 1 equals 2. Now let's look at the y. Here y again is raised to the power of 1, which is 2 minus 1. Y is raised to the power of 2, which is 3 minus 1. Y is raised to the power of 3, which is 4 minus 1. So using the same way, I can say that y always is going to equal, in the y is going to be raised to the power of r minus 1 itself. And by this, I'm going to have a complete general rule for terms. However, this rule does not look good this way. So we can make it simpler by just changing it a bit. Instead of having tr or the term r, I'm going to make it the term r plus 1. So I can get rid of the r minus 1s. And in this case, I'm going to have ncr instead of ncr minus 1 multiplied by x to the power of n minus r multiplied by y to the power of r. So if I want to find the third term, I'm going to make it t2 plus 1 instead of t3, which is the same because 2 plus 1 equals 3. And I'm going to say it equals nc2. Now r became 2, multiplied by x to the power of n minus 2 multiplied by y to the power of 2. Now, if I want to go back to the example that we set at the beginning of the video, which is x plus 1 over 2 to the power of 10, let us say that I want to find the fifth term. So to find the fifth term, first of all, I'm going to make it t4 plus 1 instead of t5, and then say that t4 plus 1 equals, now n equals 10. Remember that n is the power of the expression. So it's going to equal 10c, r is 4, multiplied by x to the power of 10 minus 4, which is n minus r, multiplied by y to the power of 4. And so, now 10c4 is 10 factorial divided by 4 factorial multiplied by 10 minus 4 factorial. 10 minus 4 equals 6, so 6 factorial, which equals 10 by 9 by 8 by 7 by 6 factorial divided by 4 by 3 by 2 multiplied by 6 factorial. 6 factorial by 6 factorial, and by 2 equals 1, by 2 equals 4. Oh no, by 2 equals 1, by 2 equals 5, by 4 equals 1, by 4 equals 2, by 3 equals 1, by 3 equals 3. And so I have 5 multiplied by 3 multiplied by 2 multiplied by 7, which equals 210 x to the power of 10 minus 4, which is 6, multiplied by y. Y is 1 over 2 to the power of 4. Now we can find 1 over 2 multiplied by the power of 4 and multiplied by this coefficient to finalize our question. Now let's move on and talk about the middle term. What do I mean by the middle term? In any expression, I'll have the term 1, term 2, term 3, term 4, and term 5. Now, term 3 here is in the middle of the expression, and this is what we mean by the middle term. This if the number of terms is an odd number, but if I have a number of terms that is even, for example, 4 terms, I cannot have, or 6 terms, I cannot have one middle term. I'm going to have 2 middle terms. Right. To find the middle term, we're going to be doing 2 things. First of all, we have to find the order of the term itself. If it's the first, if it's the second, if it's the third, if it's the fifth, if it's the seventh, whatever. And secondly, we have to find the term itself. Now, a lot of people make the mistake of confusing between the order of the term and the term itself. For example, they are asked the question to find the middle term, and then what they do is they end up in 2 lines telling you that, oh, the middle term is the fifth term. And that would be a mistake because you're not asked to find the order of the term, you're requested to find the term itself. If you're requested to find the order of the term, you can say that it's the fifth term, it's the seventh term, or anything like that. But if you are asked to find the term itself, then you have to actually find the term and write it down. But in any way, you always have to go through finding the order of the term before finding the term itself. Now, let's start by finding the order of the term. If I have an expression that is raised to the power of 4, we know that the number of terms equals the power itself plus 1. So I'm going to have actually 5 terms. And if I have an expression, or let's just leave raised to the power of 5, I'm going to have 6 terms. So the number of the terms, if it's odd or even, is going to be depending on the power of on the power itself, or depends on n. Now remember that uh, it's t r, so r goes for the order of the term. Now in case I have an odd number of terms, r is going to equal n divided by 2. So for example, if I have a bracket that is raised to the power of 4, r is going to equal 4 divided by 2, and so it equals 2. And the order of the term is going to be t. Remember that it's r plus 1. So the order of the term is going to be t2 plus 1 or t3. And so the order of the term is the third term. Remember that you find r, but then you add 1, because in the general rule, it's always tr plus 1. Now, if I have an even number of terms, then I'm going to have 2 middle terms, and they're going to be r equals n minus 1 divided by 2 and n plus 1 divided by 2 correspondingly. So if I have a bracket that is raised to the power of 5, r equals 4 divided by 2, and also r equals 6 divided by 2, and so they're going to be t2 plus 1 and t3 plus 1, which are going to be the third term and the fourth term. The third term and the fourth term here are the middle terms of this expression. Now let's have an example. If I have the expression 2x cubed minus 1 to the power of 9. Let us find, number 1, the middle term, or terms if they are 2, and number 2, let us find the term that contains x to the power of 6, or the terms that includes x to the power of 6. Solution. Now n equals 9. So to find the middle terms, first of all, If n equals 9, then I'm going to have 10 terms, which is an even number of terms, so I'm going to have two middle terms instead of one. And so r is going to equal 9 minus 1 to the power divided by 2, and 9 plus 1 divided by 2. And so the middle terms are t 9 plus 1 to the 9 minus 1 to the divided by 2 is 4, and 9 plus 1 divided by 2 is 5. So the middle terms are the fifth term and the sixth term. Now again, I'm not asked to find the order of the terms. This is the order of the terms, not the terms themselves. The question says I have to find the terms themselves. So I have to actually find term 5 and term 6. So term 5 is t4 plus 1 equals n equals 9, so 9 c4 x to the power of 9 minus 4, and y equals minus 1 to the power of r, and r again is 4. 9c4 equals 9 factorial divided by 4 factorial multiplied by 9 minus 4 equals 5 factorial, which equals 9 by 8 by 7 by 6 by 5 factorial divided by 4 by 3 by 2 by 5 factorial. 5 factorial goes with 5 factorial. By 4 equals 1, by 4 equals 2, by 2 equals 1, by 2 equals 3, and by 3 equals 1, by 3 equals 3. I'm so sorry, I did not notice that I just wrote here x. X equals to x cubed. So this is 2x cubed to the power of 9 minus 4. So the term equals 3 multiplied by 2 by 7 by 3 equals 84 multiplied by 2x cubed to the power of 9 minus 4 equals 5. Now negative 1 is raised to 4. It's an even power, so it's just going to remain like this. Now for the second one, this is the first middle term, which is the fifth term. Now for the sixth term, which is going to be t5 plus 1, it's going to equal 9 c5 multiplied by 2x cubed all to the power of 9 minus 5 multiplied by negative 1 to the power of 5. Now because 5 plus 4 equals 9, the combination is going to have the same results, which is 84, and then I have 2x to the power of 3 all to the power of 9 minus 5 equals 4, and negative 1 here is now raised to an odd number that is a power, and so it equals negative 1. So I have negative 84 2x cubed all to the power of 4. Now I don't actually, I'm supposed to actually expand this, but I don't usually, just to save time in the video, but you can do so yourselves. And so now I have found the fifth term and the sixth term, which are the middle terms. Now I need to find the term that contains x to the power of 6. So the term that has x to the power of 6. I don't know the order of this term. So it's just going to be tr plus 1. And it's going to equal 9, which is n, cr, multiplied by x. Now again, x is 2x to the power of 3 to the power of 9 minus r, and negative 1 to the power of r. Now to find the term that has the power x to the power of 6, I'm going to look at x here because I need x to the power of 6. So let's take this one by itself and work with it. So I have 2x cubed all raised to the power of 9 minus r. I'm going to expand this, and the expanded is going to be 2 to the power of 9 minus r, and x to the power of 3 multiplied by 9 is 27 minus 3r. Now I separated the x from the 2 so I can work with the x itself. What I want to get is x to the power of 6. I want to make this x to the power of 6. So I need 27 minus 3r to equal 6. I'm working with 27 minus 3r. I'm just going to make those bullet points here so that it's not confused with the rest of the with the question itself, that I'm doing different tasks. Now I'm going to solve for r. 27 minus 6 equals 3r, and 27 minus 6 equals 21. Dividing both sides by 3, I will find out that r now equals 7. And once I found r, then I can find the rest of the term. So now instead of having tr plus 1, I'm going to have t7 plus 1, which equals 9c7, 2x to the power of 3, all raised to the power of 9 minus 7 equals 2, multiplied by negative 1 to the power of 7. 9c7 equals 36. And negative 1 is raised to an odd power, so it's negative 36, because I'm just going to end up with negative 1 here, and when I multiply it with the rest, they're going to become negative. And this is multiplied by 2 to the power of 2 is 4, and x cubed to the power of 2 again is x to the power of 6. And this equals negative 144 x to the power of 6. And so now I have found the term that has, or that includes, or that contains x to the power of 6, which is actually the 8th term, or term 7 plus 1. And that is all for today's video. I hope it was enjoyable and educational. Don't forget to share and subscribe to find all the lessons that you need, and to use the comment section to write any request that you have, or if there is any particular problem or problems that you want me to solve in future videos. Thank you so much.